Silver team, along with Robbie Peoples and Brent Griffith. Our system is a spray paint booth control system. Just a quick background. We've gone over this a couple times, but there's an engine assembly plant in Dunlap, and our system is made to emulate that. With our system, both these dampers are closed, so when air is coming in, it is only pressurizing booth 1. Our input variable is motor power in percent, and our output is pressure within the booth in centimeters of water. Just a quick, I'm going to go over that. All right, this is kind of an overview on what we've done up to date. Up to, but not including this week, the stuff we've already presented is our steady state operating curve, our step response experimental step response using the FOPDT modeling, frequency response experimental, and then frequency response using the Bode plot modeling, and then the new data that we collected and I'm here to present is our root locus modeling. So I'll quickly go over the old stuff. This is our steady state plot, and our steady state operating curve for each of the 3 ranges: low, middle, and upper range. This is our step response experimental, where we ran step ups and step downs to figure delta M, delta C, and then eventually gain, time constant, and dead time, which are going to be the 3 parameters of our system that we've calculated various ways throughout all our work up to date. This is the FOPDT modeling for step response. Basically, it's a model to represent the dynamic response of a system for step ups and step downs. This is our frequency response experiment. This is the data we collected from our frequency response. Delta M, T, delta C. And here's our Bode plots from our frequency response modeling. We figured ultimate frequency, gain of our system, and the KCU, which that's the ultimate controller gain. This is our amplitude ratio plot for our Bode plots. And this is our phase angle plot for our Bode plots. So this is what we've done up to date, and I guess in a nutshell. We've been figuring the gain, the time constant, and the dead time for our system for each of the 3 ranges of pressure. And this particular chart shows what we've done from each of the 4 experiments or models we've done up to date. And you can see there's a lot of variance in all of our data. The most pertinent one is going to be the frequency response we did from the Bode modeling, which gives us our best parameters for our system, and that's what we're going to be using. That's what we used for our root locus plotting. That's what we're going to be using from here forward for our system parameters. So this is a root locus overview. Root locus is a method used to find the roots of a system's characteristic equation by plotting all the values of a system's parameters, which is a gain, dead time, and time constant. And using these parameters that we found during the frequency response modeling, we're able to find values of Kc, critical damping, 1/500th decay, 1/10th decay, quarter decay, and the ultimate Kc. So this is a kind of a generic root locus plot. This is the KCU, or the ultimate Kc. KC at critical, or I'm sorry, at the ultimate KCU. This is KC at critical damping. Everything in this range of the plot is underdamped, and everything past the critical damping is overdamped responses. And this is just a sample, one of our root locus plots. I believe this is our low range data. And so for the delta KC, we used a 0.03. Basically, we wanted it to, we wanted this to cross through this imaginary y-axis. And these are the system parameters that we got from our frequency response modeling earlier. So we did that. We did one of these for each of our 3 ranges. And this is the data we collected for lower, middle, and upper range. Got a critical damping, KC, 1/500, 1/10, quarter, and ultimate. And these numbers get smaller as the range goes up, which means as the power to the system goes up, the numbers get smaller. And this is that same data, just in a chart form. So, in conclusion, we found the roots of our system's characteristic equation using root locus plots, and we found the KC values at critical damping, 1/500 decay, 1/10 decay, a quarter decay, and ultimate KC.